Hello guys, welcome to Creators Classroom YouTube channel. So in this video, I will demonstrate how to use machine learning models in cancer genomics. Okay. So as you are aware of, artificial intelligence and machine learning, they are transforming healthcare industry and biological research. Okay. So the question is whether ML models can learn to identify what type of cancer a patient get with the help of his genome data. Okay. So today I will demonstrate with the help of random forest, okay, in the Google Collaboratory platform. So in order to understand practical of random forest, you need to understand first the basics of decision tree. So I will explain about the decision tree, then I will introduce you to random forest theory, and then we will switch into the practical to build cancer identification model step by step using the genome data. Okay, and for this specific class you no need to have advanced coding experience, okay, because all the codes are already given in the Google Colab, and I will explain how to run these codes. Okay, so by the end of this video you will understand how to load the data to Google Colab, and also how to split the data into training set and test set, then how to train the model, then how to do prediction and accuracy evaluation. Okay, so now I will explain basics of decision tree. Okay, so friends, as you can see here, a classification tree is a decision support tool. Decision tree is also called as classification tree. Okay, so a classification tree is a decision support tool that uses tree like graph or model. Okay, so basically it's a type of supervised learning. That means it requires labeled data. So what are labeled data? So I will show here. So this is the GitHub repository of mine. Okay, and I have given here the codes of random forest, and here is the data. Okay, so let me download this data. Okay, so it is a CSV data. So you can see here. So here in the first column we are having different patients and the type of cancer they are having. Okay, lung cancer, then breast cancer, colorectal cancer, and patients with no cancer. Okay, so these are called as labels, and these are all the features. Okay, so actually this is a genome SNP, genomoid SNP data. Okay, so these are all the markers. Okay, markers are SNP markers, we call it as. So one represent individuals which are homozygous for allele 1. Okay, and 2 represent they are heterozygous, and 3 represent, okay, some individuals you can see 3 represent these individuals are homozygous for other type of allele, and somewhere it is mentioned as 0. That means these individuals genotypes are not identified. Okay, this decision tree or classification tree, it will give categorical output such as yes or no type or species A, species B, and in our this example it is what type of cancer. Okay, whether lung cancer or colorectal cancer or breast cancer or no cancer, like that. And it is a hierarchical structure. Okay, that means tree consists of a root node, then internal nodes, okay, then the leaf. I will explain with the help of this diagram here. Okay, so I need to, let us assume I need to take a decision that whether I should accept a new job offer or not. Okay, so this is my decision support I want. Okay, that is, should I accept a new job offer? So here you can see this is a classification tree. The root node says what is the salary level. Okay, it is written as $50,000. Okay, so if the salary is more at least $50,000, then I will accept. Okay, that's why it is written here as yes. And if the salary is less than $50,000, definitely decline the offer. Okay, so this is here is a root node, and these are all the decision nodes. Okay, and later if the commute hour is less than or more than 1 hour. Okay, if it is more than 1 hour, that is the commute time, then you decline the offer. If the commute time is less than 1 hour, then you accept it. Okay, then whether they offer free coffee or not. If they provide free coffee, then accept the offer, otherwise you decline the offer. Okay, so here you can see in the terminal where the decisions are given, these are all the leaf nodes. Okay, and This is a root node which is written as salary at least, and others are the decision nodes. So I will show the result of one example implemented with the help of iris flower dataset. Okay, so iris flower dataset, it was given by Fisher, R.A. Fisher. It's also called as Fisher's iris data. So basically, there are three types of iris species are there. One is iris setosa, iris virginica, and iris versicolor. And the petal length, petal width, and sepal length and sepal widths are different in these three species. Okay, so using this data I have built a classification tree, or also called as a decision tree. So you can see here the root node is the iris setosa, that is petal length. Okay, the petal length is a criteria of iris setosa. Then there is a decision nodes, are the internal nodes. So this is a internal node, iris versicolor. Okay, petal width. So this is a uh, decision node. Then leaf nodes are there. Okay, so those which are painted with these colors, no, blue color, red color, then parrot green color. Okay, so these are the leaf nodes. And then there are split criteria. Okay, so based on the flower measurement, that is petal length less than or equal to 1.9 centimeter or more than 1.9 centimeter, then petal width. Okay, so these are all the split criteria on what basis you are splitting the tree. Okay, so now moving on to a random forest. So random forest, in a forest you can see multiple trees, isn't it? So you can see here there are multiple trees. So group of trees constitutes a forest. So in the random forest, basically we will be building multiple decision trees. Okay, so this is decision tree 1, this is 2, this is tree number 3. Okay, likewise. So my purpose here is to build a model. In this case, okay, in this figure, my purpose here is to build a model to identify the fruit. Okay, so let's say two models here, they have identified it as apple, and one tree has identified it as a banana. That means, so majority of the trees, they have identified it as banana. So my final answer will be banana. Okay, so depending on the votes, means how many trees are opting for apple here. Okay, so we'll go for voting, and based on that we'll finally choose the output. So random forest, nothing but it's a group of decision trees. Okay, it's a ensemble model of decision trees. So here the definition is random forest is an ensemble learning method that operates by constructing multiple decision trees during training and outputting the class or the classification output. Okay, so the advantage here is it reduces overfitting and also the variance. So moving on to our practical now. Okay, so what we will do here is using this cancer data which I have shown. Okay, so using this cancer data, so these are the individual, means patients which are having different types of cancer, and these are the genomoid smp markers. Okay, so using this genetic data we'll train the model. Okay, then also we'll predict the accuracy. Okay, and I will show all these things with the help of Google Colab. Okay, so now in this folder I will go to random forest Colab notebook. Okay, so it is loading. Once it opens, then you need to click on the open in Colab ribbon. Okay, so if you click on open in Colab, it will take you to Google Collaboratory. Okay, so this is the landing page of Google Collaboratory. So immediately after opening Google Collaboratory, you need to connect. Okay, you need to connect to a run type. Okay, so mine is already connected. If it is connected, then it will display this RAM, what is the RAM, what is the disk space they have allotted, all these things. Okay, so now what we'll do is we will import the libraries. Okay, important libraries required for implementing random forest. Okay, so first one is we need numpy. Okay, numpy is required for numerical operations. Okay, then we need pandas. Okay, which is required for reading, manipulating and analyzing tabular data. Then we need matplotlib. Okay, which is required for creating the plots. Then cburn is also used for creation of plots. Then we need a train test split. Okay, so this is required for splitting the data into train set and the test set. Okay, and we also need a random forest classifier. Okay, so this is actually the library of sklearn or scikit-learn used to build the random forest. Then again from the same scikit-learn we are importing confusion matrix to construct confusion matrix to know the accuracy and also to give some reports. Then we are also importing the label encoder. Okay, so label encoders, so here what type of cancer each patients are having, like lung cancer, breast cancer. Okay, these are the labels and we need to encode them. Okay, for example, breast cancer as one, then liver cancer as two. Okay, so likewise we need to encode these names of the cancer into the numerical numbers so that the building process of models are easy. And also we are setting here the seed to 42 so that the results can be reproducible. Okay, so even if you rerun this Google Colab notebook in your computer, you will also get the same results because I am setting the random seed into 42. Okay, so now what we'll do is we will upload the data. See, so this is the button to upload the data. Okay, so you need to click this button and choose this data. Okay, CSV format where our patient's data and genetic data is there. It is showing some warning, you just click OK. Okay, you can see here common cancers is there. So after uploading the data, now you load this data to the working space. Okay, so yeah, first I forgot to import this. Yeah, once if I click this play button, these codes will run. Okay, so after successful run of each code or code block, it will give the right mark. Okay, so here it has taken 0 seconds to run this code block means a group of codes. So now we will run this code block. Okay, so here you can see with the help of pandas read CSV option, we are uploading means importing our data common cancers.csv into the working space. Okay, then also we are printing the data shape using data.shape, and also we are printing the first few rows of the data. Okay, and also we are identifying the missing values. Okay, so for those patients where the particular SNPs are not identified, okay, where it was written 0. So let us see how many individuals and how many markers are there. So you can see here the data shape 262 rows are there. That means these many number of patients are there, and 646 means these many number of columns. That means these many number of genomoid SNP markers are present. So now we will move on to data pre-processing. Okay, so why we need pre-processing? So if you do not follow pre-processing step, that means separation of features and the label, then proper splitting of the data, you may end up in obtaining the less accurate model. Okay, so what we need to do here is in data pre-processing, first we need to separate features from the labels. Okay, so in our case the features were SNP markers and the labels were the type of cancer each patient they were having. Okay, and after separation of features and the labels, what we are doing is we are assigning the data. Okay, x variable is assigned as all the future except individuals, that's why it is written as data dot drop, and y variables is assigned as individuals. Okay, and we need to encode, as I was saying, with the help of label encoder feature we are encoding, let's say lung cancer as 0, breast cancer as 1, colon cancer as 2. Okay, it depends on how many types of cancers are present in the data set. Okay, and after that we are splitting the data. Okay, you can see here x train x test, then y train y test. So y variable is actually having the labels and x variable is actually having the features, that is SNPs here. So with the help of train test split feature, so we will divide it into train and test for the features and also train and test for the labels. Okay, so and what is the test size? Okay, that means it is 0.2, written as 0.2. That means the training data is 80% and the testing data is 20%. So let me run this. So it is saying, so it is displaying the training set shape which is 209 individuals and 645 markers, and the test shape as so 53 individuals are the patients and 645 features. Okay, so now with the help of random forest classifier, okay, so this feature will going to build the random forest. So before actually running this code, you need to set some of the parameters. Okay, so the number of estimators, that means how many decision trees you need. I told in the beginning that random forest means it's a group of decision trees. Okay, so here we are opting 100 decision trees. Okay, then maximum number of features to be used. Okay, so for the random forest classification, usually we will take square root of number of features. Okay, so that's why I have mentioned as square root. So square root of total number of features, that means here the number of features were 645 SNPs were there, so square root of 645, so something around 24 or 25 will come. So those many maximum features we will keep for building the model. Then you need to set the maximum depth of each decision tree. Okay, so none, the word none means trees grows until all leaves are pure or cannot be split further. Okay, cannot be split into further. What is splitting, I have told in the theory already. Then minimum number of samples required to split an internal node. Okay, so here we are setting it as 2. So you can play with this by varying these numbers. Okay, instead of 2 you can set it to 3, set it to 1, and see how the accuracy or how best the accuracy of model you are obtaining. And minimum number of samples I am setting it as 1, and bootstrapping I am mentioning it as true. That means I'm opting for bootstrap sampling. Let's say you are having 100 balls, so I will randomly select the 10 balls from the basket, and then I will put them back after recording. Okay, again I will pick the 10 balls from that basket, and here the ball which is already picked in the previous round is also having equal chance to pick up in the second round. Okay, so that is the meaning of bootstrapping. Then again I am setting random state as 42 because in order to reproduce the results. Okay, so finally I am fitting the model. Okay, I am fitting the random forest model using x train data and y train data. So what is x, that is features. Okay, and what is y, that is labels. So let me run it. So in no time, it the code successfully ran. Okay, you can see here the right tick mark, and it has taken 0 second. Okay, so Google Colab is a very powerful platform for like many of the data sets. Now it's time for making the predictions and evaluate the accuracy of the model. Okay, so for prediction what I am taking is I am taking the developed model. Okay, RF model which we have developed here. Okay, RF model, and based on the features, okay, based on the test set features, that is test set SNP markers, we are predicting the labels. That means what type of cancer the individual patient is having. Then based on the actual labels and the predicted labels, we will construct the confusion matrix to see the accuracy, percentage of accuracy of that matrix. Okay, and this is the code for constructing the confusion matrix plot. Okay, so now I will run this code. So you can see a beautiful confusion matrix is appeared. Okay, the label 0 indicates the first type of cancer in the data, that is the lung cancer. Okay, so you can see here 0. So in our test sample there were 5 individuals. Okay, 1 plus for 5 individuals. So out of 5 individuals, 4 were correctly predicted as the patients with lung cancer, and 1 individual is predicted wrongly. Okay, so likewise, so usually you should have the numbers in the diagonals only. Okay, and all the non-diagonal elements should be 0. That indicates the 100% accuracy. Okay, so here some accuracy metrics are there for each type of cancer. Okay, in our data set we had breast cancer, colorectal, esophageal, gastric. Okay, different type of cancers were there, and the average accuracy. Okay, so the average accuracy was around 97%. Okay, now we need to extract the feature importance. Okay, out of all the 645 SNP markers, which are the SNP markers which are most helpful for identification of different type of cancer. Okay, so you can see I'm using this importance. Okay, RF model, that is random forest model, feature importance. Okay, so and also later I am sorting it based on the importance score. Okay, and I am constructing some bar graph. So you can see this marker. Okay, marker with the last three digits 728 is the most important feature to classify different types of cancer. And also so these are the top 10 markers, okay, are the features, important features. And also you can see, so the features and their feature importance, and it is the position. Okay, so what column this, in what column this marker is present. Okay, so in 381st column this marker is present. Okay, and this marker is present in the 13th column. Okay, so we can cross verify. So 490, so 13th is 1 2 3 4 5 6 7 8 9 10 11 12 13. Yeah, this one, because actually we have removed these labels, no? So that's so. So you can see the 13th column in the features is this 490. Now this is most important. So now we need to freeze the model. Okay, we need to freeze the developed model. So for that we are using joblib. Okay, it is a popular library in the Python. So what I'm doing is I am dumping, that means I am converting our developed random forest model into random forest model dot joblib. Okay, and also I am saving the label encoder as label encoder dot joblib. Okay, so after pressing here, you can see this label encoder joblib and random forest model joblib, they are appearing in our files. Okay, so now it's actual time for predicting the new samples. Let's say I have developed the model now. So few patients will come. Okay, so to the hospital, few patients will come to the hospital. So you need to predict what type of cancer these patients are having based on the genetic data. Okay, you don't have any history. Okay, so without having any other diagnosis, simply based on the genome SNP markers collected, identified with their genomic DNA collected from the blood, we can able to identify. Okay, so for that what we'll do is we will upload the model first. Okay, so means already it is there in the files, so simply we will attach to the working space. Okay, so I am attaching both the random forest model and the label encoder. You can see here model and label encoder are loaded successfully. Okay, so now what we'll do is we will download some samples.csv. Okay, then we will upload here. Okay, and we will predict what type of cancers they are having. So what I will do is, so in the same folder which I have given, okay, there it was having the data. So ml in genomics, you can see here samples.csv. So I will download this data. So here the labels are not there. That means these are the new patients. They do not yet diagnosed it what type of cancer. Okay. Now our task is based on the genome SNP markers. You need to predict what type of cancers these patients are having. So what we'll do is we will upload that samples data. So now what we'll do is with the help of pandas, we will attach our samples.csv. Then with the help of loaded RF model, we are predicting our samples. Then also with the help of a label encoder, we are encoding our actual labels. Okay, so we'll run this. We can see the sample one or the patient one is having lung cancer. Then the patient 2 is having breast cancer, patient 3 is having colorectal cancer, and patient 4 is having no cancer, means the healthy individual. Okay, so you can see simply with the help of genome SNP markers, okay, we have built a random forest model, and that is actually able to tell whether an individual is having cancer or not. Or since these SNP markers, they are fixed at the birth itself. Okay, so with the help of these markers and this built RF model, we can say whether a particular individual is going to get cancer or not, and if they get cancer, what type of cancer they can get. Okay, so this is about the application of machine learning in cancer genetics, guys. So if you like this video, please subscribe, like, and share with your friends. And also if you want me to make more videos on science and technology, please encourage us by subscribing, because if you see any other YouTubers, what they'll do is they will add a lot of edits and musics in the background, so that the video they will visually look appealing, but you will not retain any topics. Okay, so because we are typically our mind is trained to learn some topics in a classroom setting. So in our creators classroom YouTube channel, so I am not going to add any edits, I'm not going to add any background musics. Okay, simply me and you. Okay, with the with some topics being demonstrated. Okay, so please encourage us guys by subscribing. Thank you so much.